September 7th, 1942, Kaiser Richmond Shipyard No. 2, California. The welding torches fell silent as the last steel plate was positioned on the hull of what would become the SS Robert E. Peary. German naval intelligence officers stationed in neutral countries had been tracking American shipbuilding statistics for months, but the numbers arriving at Berlin seemed impossible to believe. American shipyards were claiming construction times that violated every principle of maritime engineering accumulated over 3,000 years of seafaring history. The mathematics of naval warfare were about to be rewritten not through superior firepower or advanced technology, but through something the German naval establishment had never prioritized: industrial mass production applied to shipbuilding with devastating effectiveness that would fundamentally alter the balance of power on the world's oceans. Traditional shipbuilding wisdom, developed across centuries of European maritime tradition, established clear limits on construction speed. Master shipwrights in Hamburg, Bremen, and Kiel understood that quality vessels required careful craftsmanship, precision fitting, and time-tested techniques that could not be rushed without compromising seaworthiness. German U-boat commanders operating in the Atlantic had calculated their success based on these established construction rates, assuming that sinking Allied vessels faster than traditional yards could replace them would eventually strangle British supply lines and force negotiation. They had not accounted for Henry J. Kaiser, a man who had never built a ship in his life but possessed something more valuable than maritime experience and der standing of American industrial capability that German planners fundamentally underestimated. The transformation began in the most unlikely place possible. Kaiser had spent his career moving mountains, literally. His construction company had built the Hoover Dam, the Grand Coulee Dam, and massive highway projects across the American West. When the British government desperately needed cargo vessels in 1940, Kaiser saw an opportunity that traditional shipbuilders dismissed as impossible. The established yards in Newport News, Bath Iron Works, and Brooklyn Navy Yard possessed decades of experience, skilled craftsmen, and proven methods. They also possessed something Kaiser recognized as a fatal limitation: an acceptance of conventional wisdom about what could and could not be accomplished within existing timeframes. Kaiser's first contract called for 30 cargo vessels to be delivered within 2 years. Maritime experts calculated this schedule as optimistic but achievable using conventional methods. Kaiser had different plans. His engineering teams visited automobile assembly plants in Detroit, studying production techniques that the shipbuilding industry had never considered applicable to maritime construction. What they discovered would revolutionize not just American shipbuilding, but the entire concept of wartime industrial mobilization. The assembly line principles that Henry Ford had perfected for automobiles could be adapted to ship construction with modifications that no traditional shipbuilder had imagined possible. The skepticism from established maritime authorities was immediate and intense. Admiral Emery Land, chairman of the United States Maritime Commission, reviewed Kaiser's proposed methods with deep concern. His private correspondence revealed the maritime establishment's reaction to Kaiser's unconventional approaches. Welding had never been proven reliable for large-scale hull construction. British naval regulations specifically prohibited welded hulls on warships due to concerns about structural integrity under combat stress. Kaiser was proposing to stake America's merchant marine capability on techniques that violated every accepted standard of proper shipbuilding practice. Yet necessity created opportunities for innovation that peacetime conditions would never have permitted. German submarines were sinking Allied shipping at rates that traditional construction methods could never match. In 1941 alone, over 3 million tons of Allied vessels disappeared beneath the Atlantic waves. British food supplies were reaching critically low levels. The mathematics were brutally simple. Unless American shipyards could produce vessels faster than German torpedoes could sink them, Britain would be starved into submission regardless of American willingness to provide aid. Traditional methods promised defeat. Kaiser's untested approaches offered the only possibility of survival. The Richmond shipyard that rose from California mudflats between January and December 1941 horrified traditional maritime engineers while simultaneously fascinating them. Instead of the longitudinal building ways that had characterized shipyards since ancient times, Kaiser's facility resembled something entirely different. The layout borrowed directly from automobile manufacturing, with parallel assembly areas surrounding prefabrication zones where entire ship sections could be built simultaneously. Overhead cranes capable of lifting massive steel assemblies stood ready to move completed components with precision that traditional methods had never achieved. Railroad tracks crisscrossed the facility, designed to transport hull sections weighing hundreds of tons from fabrication areas to final assembly positions. John Riley, Chief Naval Architect for Bethlehem Steel Corporation and a 30-year veteran of traditional shipbuilding, visited the Richmond facility in May 1941. His confidential inspection report captured the established industry's mixture of criticism and reluctantly growing respect. Kaiser had violated fundamental principles of efficient shipyard design that Riley had learned through 3 decades of experience. The prefabrication areas seemed unnecessarily large. The crane capacity appeared absurdly excessive for normal operations. The building ways were shorter than conventional wisdom demanded for proper ship construction. Yet Riley admitted that the facility was designed perfectly for exactly what Kaiser claimed he would accomplish: rapid assembly of prefabricated sections into complete vessels. The workforce that began arriving at Richmond in August 1941 represented another revolutionary departure from traditional maritime practice. Established WWII shipyards recruited from maritime communities, where skills passed from father to son across generations. Kaiser advertised in newspapers across America, offering wages 20% above standard industrial rates and promising to train anyone willing to work. The first groups included former farmers, housewives, secretaries and labourers who had never seen the ocean, much less built vessels to sail upon it. Traditional shipbuilders watched this development with horror, convinced that inexperienced workers would produce vessels that would fall apart in the first storm. Kaiser's training programs simplified complex shipbuilding tasks into repetitive operations that could be learned quickly. Traditional welders spent 4 years as apprentices, mastering comprehensive skills. Kaiser's instructors taught specific techniques for specific tasks in approximately 2 weeks. Workers did not need to understand every aspect of ship construction, only how to perform their assigned operations repeatedly and efficiently. A welder responsible for vertical hull seams learned to execute those welds perfectly without needing to understand horizontal deck welding or curved bow section techniques that other specialists would handle. By October 1941, Kaiser employed over 10,000 workers at Richmond, with fewer than 200 having any previous maritime experience. This workforce, dismissed by traditional builders as hopelessly inadequate, began achieving results that challenged every assumption about shipbuilding requirements. The learning curve accelerated as workers gained experience through repetition. Tasks that initially required hours began taking minutes. Operations that seemed impossibly complex when first attempted became routine through systematic practice and specialized training. As construction speeds increased through late 1941 and early 1942, something unprecedented in maritime history began occurring. Ships that traditional methods would have required 8 months to complete were sliding down the ways in less than half that time. Kaiser's first Liberty ship took 197 days from keel laying to delivery. The second required 169 days. The fifth took 128 days. By ship number 10, construction time had fallen to 97 days. Traditional shipbuilders watched these developments with growing alarm, recognizing that fundamental assumptions about shipbuilding limitations were being systematically demolished by a man who had never built a ship before entering the industry. The prefabrication approach that maritime experts had dismissed as impractical proved devastatingly effective in actual operation. Instead of building ships sequentially from keel to superstructure, Kaiser's yards fabricated entire sections simultaneously across the facility one. While crew assembled bow sections in dedicated areas, other teams built stern assemblies, engine rooms, deck houses, and cargo holds in parallel operations. When individual sections reached completion, massive cranes lifted them onto building ways where specialized welding crews joined them together into complete vessels. Albert Wooding, production supervisor at Richmond Yard No. 2, explained the revolutionary efficiency to Fortune magazine reporters in early 1943. Traditional shipbuilding required sequential construction where each phase depended on completing previous stages. You could not install engines until engine rooms were finished. You could not complete engine rooms until hulls were assembled. Everything happened in rigid sequence, creating bottlenecks that extended construction time regardless of available workforce. Kaiser's parallel production eliminated these constraints entirely. While one crew welded hull plates in the main assembly area, separate teams assembled complete engines in dedicated workshops. When both components reached completion, cranes positioned the finished engine into the completed engine room during a single 8-hour shift. Operations that previously consumed weeks now required hours. The statistics emerging from Richmond defied maritime engineering assumptions that had remained unchallenged for centuries. Traditional shipyards assigned 50 workers to engine installation over 3 weeks, labouring in cramped conditions within partially completed vessels. Kaiser's approach assigned 200 workers to complete engine assembly in open workshops over 5 days, then moved the entire unit into position using mechanical precision that eliminated manual handling inefficiencies. More workers completing tasks in less time while achieving superior results contradicted everything traditional builders understood about labour productivity and quality control relationships. Competition developed among Kaiser's 7 shipyards spread across California, Oregon, and Washington as construction speeds continued accelerating through spring 1942. Edgar Kaiser, serving as vice president and overseeing Pacific Northwest operations, managed the Oregon Shipbuilding Corporation in Portland. Clay Bedford controlled the Richmond facilities in California. Both men, driven by ambition and competitive instincts, began informal contests to determine whose yards could build ships faster. The rivalry became a public spectacle as newspapers published construction records like athletic achievements, creating pressure for continuous improvement that traditional shipyards had never experienced. The competition reached its climax in September 1942, when Oregon Shipbuilding completed the SS Joseph N. Teal in just 10 days from keel laying to launch. The achievement stunned maritime observers who had considered Kaiser's previous records impressive, but assumed natural limits would prevent further acceleration. 10 days represented a construction speed that violated fundamental assumptions about steel fabrication, welding requirements, and assembly complexity. Vice Admiral Howard Vickery eventually ordered the speed competitions discontinued, declaring them publicity stunts that distracted from actual production goals. Yet the competitions had achieved Kaiser's underlying purpose. Workers across all 7 yards now believed extraordinary speed was not merely possible, but expected. German naval intelligence officers monitoring these developments from neutral countries filed reports that Berlin initially dismissed as exaggerated or fabricated. The numbers seemed impossible according to every German understanding of industrial capability and maritime construction requirements. German shipyards, among the most advanced in Europe, required 6 to 8 months to complete vessels similar to American Liberty ships. The idea that untrained American workers could build equivalent vessels in weeks contradicted German technical expertise and industrial experience accumulated over decades of naval construction programs. Kriegsmarine analysts studying Allied shipping replacement rates recognized the strategic implications if American claims proved accurate. German U-boat operations were predicated on sinking merchant vessels faster than Allied yards could replace them. Submarine warfare mathematics depended on maintaining destruction rates that exceeded enemy production capacity. If American yards could actually build ships in the timeframes being reported, the entire German strategy for winning the Battle of the Atlantic would require fundamental reconsideration. Admiral Karl Dönitz, commanding German submarine operations, reviewed intelligence reports about American shipbuilding with growing concern through late 1942. His staff calculations showed that German submarines were sinking approximately 700,000 tons of Allied shipping monthly during peak operations. Traditional Allied shipbuilding capacity could replace perhaps 400,000 tons monthly using conventional methods. The mathematics supported continued submarine warfare as a path to eventual victory through economic strangulation. However, if American production claims were accurate, Allied replacement capacity might soon exceed German destruction rates, fundamentally altering the strategic balance. November 1942 brought the ultimate test of Kaiser's revolutionary methods. Vice Admiral Emery Land, visiting Richmond to inspect operations, made an offhand comment to accompanying journalists that was overheard by Clay Bedford. The Admiral remarked that Liberty ship construction had improved remarkably from initial timeframes, but noted that recent speed records still seemed modest compared to achievements in other American industries. Bedford interpreted the comment as a challenge to demonstrate the full potential of prefabrication techniques applied to maritime construction. Bedford proposed to Vice Admiral Land that Richmond Yard No. 2 would attempt to build a complete Liberty ship from keel, laying to launch in under 10 days, cutting the Oregon record in half. The proposal seemed impossible even by Kaiser's revolutionary standards. 5 days represented a construction time frame that would require perfect coordination among thousands of workers, flawless execution of complex assembly procedures, and elimination of every possible delay or inefficiency. Land, skeptical but intrigued by the implications for wartime production, authorized the attempt on condition that regular construction schedules would not be disrupted. The ship selected for the record attempt would be the 47th hull built at Richmond Yard No. 2, designated the SS Robert E. Peary after the Arctic Explorer. Starting at 1 minute past midnight on Sunday, November 8th, over 1,000 workers operating in carefully coordinated shifts would attempt something unprecedented in maritime history. The prefabrication strategy that had revolutionized normal construction would be pushed to its absolute limits in pursuit of a speed record that would demonstrate American industrial capability in terms that even skeptical German observers could not dismiss. Every major component had been manufactured, inspected, and positioned before the keel touched the building way. The bow section, comprising more than 50 individual pieces, had been completely welded and equipped with anchor machinery, chain lockers, and forward crew quarters before assembly began. The stern assembly included finished steering gear, propeller shaft housing, and aft accommodations. 4 complete cargo holds, each representing a massive rectangular structure of welded steel, waited to be lifted into position. The engine, a 140-ton triple expansion steam plant manufactured by Joshua Hendy Iron Works, had been mounted on its foundation structure and tested before leaving the factory. Where conventional shipyards built vessels from keel to superstructure over months of sequential construction, Kaiser's revolutionary approach would assemble a nearly complete ship from prefabricated sections in days. The mathematics of parallel production were about to receive their ultimate demonstration in full view of maritime observers who would carry the results back to naval authorities worldwide, including German intelligence services that were already struggling to comprehend American industrial capabilities that defied European understanding of manufacturing limitations and workforce productivity. 4 days into construction, observers from the Maritime Commission watched in stunned silence as the hull of the SS Robert E. Peary took shape with mechanical precision that seemed to defy physical laws. Massive steel sections moved through the air like pieces of an enormous puzzle, guided by crane operators who had learned their skills just months earlier. The welding crews worked in synchronized patterns, their torches creating cascades of sparks that illuminated the facility 24 hours daily. German naval attachés stationed in Washington filed urgent cables to Berlin, describing industrial processes that contradicted every European assumption about manufacturing complexity and workforce requirements. The psychological impact on traditional maritime authorities proved as significant as the physical achievement itself. Representatives from established shipyards arrived at Richmond expecting to witness either catastrophic failure or a compromised vessel that appeared complete but lacked structural integrity. What they encountered instead challenged fundamental beliefs about craftsmanship, quality control, and the relationship between construction speed and seaworthiness. The ship, taking shape before their eyes, exhibited welding quality that matched or exceeded conventional standards, while being assembled at speeds that violated every principle of proper maritime construction practice. John Bunker, representing the Bath Iron Works and carrying 3 decades of shipbuilding experience, walked the length of the growing vessel during the 3rd day of construction. His inspection revealed welding techniques that achieve superior penetration and strength compared to traditional riveted construction methods. The prefabricated sections fitted together with tolerances that exceeded specifications, demonstrating manufacturing precision that conventional wisdom claimed was impossible without extensive hand-fitting and adjustment. Bunker's confidential report to his superiors captured the maritime establishment's forced recognition that everything had changed permanently. Kaiser has achieved what our industry considered physically impossible by refusing to accept our limitations as absolute truths. His workers, dismissed by traditional builders as inadequately trained, are producing vessels that exceed our quality standards in a fraction of our construction time. The implications extend far beyond individual ship construction to fundamental questions about industrial organization and manufacturing philosophy. Workers themselves began recognizing they were participating in something unprecedented as the 4th day progressed. Mary Henderson, a former secretary from Oakland who had learned welding techniques just 6 weeks earlier, found herself responsible for critical Amazon hull AC supplies across vessel that would carry vital submarine-infested waters. Her training had focused exclusively on the specific welding patterns required for vertical hull joints, but through repetition she had achieved skill levels that traditional apprenticeships required years to develop. The specialization that maritime experts criticized as inadequate proved devastatingly effective when applied systematically across the entire workforce. The engine installation that began during the 3rd day demonstrated the full power of Kaiser's parallel production philosophy. Traditional shipyards installed engines after completing hulls, requiring workers to maneuver massive components through restricted spaces using manual techniques that consumed weeks. Kaiser's approach positioned the complete engine assembly into the finished engine room during a single, coordinated operation lasting 8 hours. 200 workers had assembled the power plant in dedicated workshops, while hull construction proceeded simultaneously, eliminating the sequential bottlenecks that constrained conventional methods. As dawn broke on November 12th, less than 5 days after construction began, the SS Robert E. Peary stood complete on the building ways. Every system had been installed, tested, and approved for service. The vessel that traditional methods would have required 6 months to build was ready for launch after 4 days, 15 hours and 29 minutes of continuous construction. Vice Admiral Land, present for the launching ceremony, addressed the crowd of observers with words that acknowledged the transformation of American industrial capability and its strategic implications. The SS Robert E. Peary that slid into San Francisco Bay that November afternoon carried more than cargo capacity across the waves. It carried proof that American industrial ingenuity, when unleashed from the constraints of tradition and empowered by necessity, could accomplish what experts declared impossible. Kaiser's revolution in shipbuilding demonstrated that the greatest limitations often exist, not in physical reality, but in accepted assumptions about what can be achieved. The Liberty ships that followed would help win a war, but the lesson they taught about human potential when properly organized and challenged remains as relevant today as it was in those desperate wartime months when the fate of nations hung in the balance.